Here I'd like to take a quick look at some interesting aspects of the carbon cycle. This graphic shows different components of the carbon cycle: the atmosphere, the biosphere, the oceans, an important part, and also the geosphere down here, as well as some human activity, fossil fuels stored in the deep earth, and the extraction of fossil fuels, burning of fossil fuels, and pumping of carbon into the atmosphere. The black numbers indicate pre-industrial times before 1800, and the red numbers represent human activities. The storage of carbon in the different reservoirs, for example the atmosphere, have units of gigatons, and the transfer of carbon from one reservoir to another has units of gigatons of carbon per year. These numbers were published in the IPCC report 2007, the Intergovernmental Panel on Climate Change 2007 report, and they're estimates for 1994. So they're a little bit outdated, but the idea is still very important. That the numbers that we'll play with and look at are still very relevant to today's time. Okay, here's a question we can take a look at. How much carbon have humans put into the atmosphere? Well, that's a fairly easy one because that's estimated down here. 244 gigatons total carbon have been put into the atmosphere from human activity. In 1994, the rate at which that carbon was being pumped into the atmosphere from the consumption of fossil fuels was 6.4 gigatons of carbon per year. Okay. And then what fraction of this total is still in the atmosphere? Well, this figure says that the total amount of carbon in the atmosphere in 1994 was 165 gigatons, and 244 gigatons was the total amount of carbon that was pumped into the atmosphere. So 68% of all carbon that was pumped into the atmosphere was still in the atmosphere in the year 1994. This is fairly relevant because it shows that once carbon is put into the atmosphere or into the climate system, it's very, very difficult to get it out. It stays in the climate system for a very, very long time. In fact, the only way that you can ultimately get carbon out of the atmosphere, or out of the climate system I should say, is through plate tectonics and seafloor subduction. Carbon settles to the bottom of the ocean in the form of shells, carbonaceous shells, and things like that, and ultimately through plate tectonics is drugged back deep into the Earth's interior where it can cycle back through. Here's another question. What fraction of the total anthropogenic carbon emissions is from land use changes? Well, this is also a fairly easy one to get. Here we have the flux of carbon from the combustion of fossil fuels as 6.4 gigatons of carbon per year, and the flux of carbon into the atmosphere from land use change is about 1.6 gigatons of carbon per year. So the total is 8, and 1.6 of that 8 is from land use changes. So roughly about 20%. And again, these are 1994 numbers. In the year 2010, this number here from fossil fuel combustion was closer to 9, and this number here dropped down and was closer to 1. And so the land use changes, the contribution to carbon emissions, anthropogenic carbon emissions from land use changes, dropped from 20% in 1994 to roughly 10% in the year 2010. How do emissions from volcanic eruptions, seafloor spreading, and outgassing compare with those from human activities? Well, we already saw that human activities in 1994 contributed to about 8 gigatons of carbon per year going into the atmosphere. Now, to get a handle on the volcanic eruptions or seafloor spreading outgassing, we can look at the removal rate of carbon via ocean sedimentation and subduction. And that is estimated here to be about 0.2 gigatons of carbon per year removal rate. When the natural climate system is in balance, the rate at which carbon is being removed from the climate system matches the rate at which carbon is being emitted into the climate system through volcanic eruptions and things like that, outgassing. And so this is a pretty good estimate as to the natural source of carbon from volcanic eruptions and outgassing each year, 0.2 gigatons, which represents only about 2.5% of the anthropogenic carbon emissions. So the one reason I put this out here is because I've often heard the argument that carbon is naturally emitted into the atmosphere by volcanic eruptions, so why worry about a little human activity? Well, this graphic shows that human activity far outweighs the natural emissions of carbon from volcanic eruptions. So those three ideas I think are worth keeping in mind.